Here we're going to look at a question on series and parallel circuits as well as safety features. Pause the video now and try all parts of this question. Part I, very simple. We state this equation: power is current times by voltage or times by potential difference. In symbol format, IV, although we should always write it in words. Calculate the current in the heater. Well, we need to rearrange this equation for current. So current is power divided by potential difference. So 2000 divided by 230, which is 8.7 amps. So which one of these fuses should be used with the heater? Well, we always need to use the smallest fuse that is bigger than this value. So we can't use 1, it would melt. Can't use 5, it would melt. Can't use 7, it would melt. So we use 13. So it's big enough to hold this current, but it's not so big that we could have dangerous levels of current. What is an advantage of series and parallel? So when they're in series, they're in a row, they're in a line, and we can use one switch to control both, which seems a little bit odd because in a heater you might think, well, I only want one on at a time if I only want it on half power, but this is what examples often consider as an advantage. In parallel, an advantage is if one breaks, the other still works, and obviously half a heater is better than no heater. Describe how an earth wire acts as a safety feature. So an earth wire provides a low resistance path for the current to flow. So if there is a fault, the current passes through the earth instead of you. Okay, and what does that do? That obviously stops you being electrocuted. Okay, you are a higher resistance than the earth wire, so the current is much more likely, or much more of the current will go through the earth wire than will you. Why should this heater be fitted with an earth wire? Well, there's a big clue here. It has a metal case which could become live if there is a fault. So what do I mean by if there is a fault? Well, supposing inside the heater, the wire coming in and the wire coming out, they are obviously attached to the heating element. Supposing one of these breaks off and maybe it touches the outer case, well then the outer case will also be at 230 volts, which means that if you touch the case, that electricity will pass through the metal case, through you, through the ground, and will electrocute you. But if there is an earth wire, the earth wire provides a low resistance path, so the electricity will then go through the metal case, through the earth wire, and back to the ground that way, and not through you.